Viewers, we'll be back from the break. It's now example 3. We are solving for x in this equation. What is regarded to be an equation is a mathematical expression with equal signs. If this never had equations, we would just stop on expression. So a mathematician should be using a correct or the proper language of math. Now, this is an examination type question. Most of the numbers we are going to experience or to encounter in exams, they will require the change base rule. In the first two examples, we have not yet changed base. But this one now requires change base rule because I'm seeing a base 3, a base x. We have to work in one base. Now, equations of logarithms, in most cases, the hidden technique inside them, they bring out a quadratic equation. After changing the base. So you should be knowing how to solve quadratic equations by factorization. That is the hidden. So the supplementary knowledge on simplification of logarithm is solving or knowing how to solve quadratic equations by factorization. How can we factorize? So on top of the laws of logarithms, quadratic equations are also coming in. Hope you saw this in indices. We are bringing in quadratic equations in in index equations or equations of indices. Now let us go and see in our solution. We shall come and say, Mr. Examiner, sir, this is the solution. Extract the equation into our workspace. So this is log the 3 of x plus log this x of 9 is equal to 3. Okay, so the base is not the same. I can change to the same base. Let me change to base 3. Okay, so changing to base 3, that is the first change by applying the change base rule. So plus log base 3 of 9 over log the 3 of x. Hope you still recall our change base rule. Then this is equivalent to 3. However, I can simplify this. I'm saying this is bringing in an integer, a non-logarithmic number. How? If I make 9 a 3 squared, a 2 will come here. I remain with log the 3 of 3. So that is also a change. Can you think about that and write it? So we shall have a log the 3 of x plus now a 2 log the 3 of 3. This 2 has come from here to make a 9. So all over log the 3 of x, which is equal to 3. Then I can tell the examiner, Mr. Examiner, sir, let log the 3 of x is equal to maybe p. You can choose any letter, you can choose a z, you can choose m, you can choose n, anything you feel like. So in this equation, where I happen to see log the 3 of x, I'm going to substitute it with p. So this is going to become now an equation without logarithm. Let us go and substitute. So this will become p. So this implies p plus 2 over p is equal to 3. Very interesting. This is 2. Log by 3 of 3 has become 1. Okay, from the supplementary law. Here we have put p, here we have put p. Get the LCM or multiply through by p and then correct like terms. Rearrange. So this will give us a p squared minus a 3p. I'm multiplying through by p, by p, by p. So p times 3, 3p. 3p comes this side, becomes a minus. That's why I'm having a negative 3p. Then times a p, I'm having a p squared. Then times a p cancels out from here. But still on the left-hand side, so plus 2 is equal to 0. This is a quadratic expression or an equation. Since it has equal signs, you can compare it with ax squared plus bx plus c is equal to 0, where a is the quadratic coefficient, b is the linear coefficient, c is the quadratic constant. Automatically, it is a polynomial of degree 2. Okay, now if it is a polynomial of degree 2, it is a quadratic equation. A quadratic equation which needs to be factorized. I'm not going to take you through the processes of factorization. We saw these in indices. Okay, so this implies that the whole of this, when we factorize, it will become, okay, I'm seeing the product of quadratic coefficient and quadratic constant is 2. So factors of 2, 1 and 2. So negative 1, negative 2. So p minus 1 into p minus 2 is equal to 0. Okay, I've factorized. Oh, so my new students are getting lost. Okay, let us go and factorize together. Sign work here. We have a p squared minus 3p plus 2 is equal to 0. So the trick is multiply the quadratic coefficient with the quadratic constant, q. So you get now a 1, which is the quadratic coefficient, times 2, which will give us a 2. Then plus this, we combine, okay, the maximum power of the polynomial, such that we get this product. So get two numbers such that when you multiply them, you get a 2. And when you add them, their sum gives us the linear coefficient, together with its sign, which is a negative 3, the linear coefficient, because this is a quadratic equation in P. Okay, so these numbers, we don't guess them, but we get the factors of the product, factors of 2, numbers which will divide 2 and leave no remainder. Okay, so these counting numbers, we shall have 1 and 2 only, because 2 is a prime number. It has only 2 factors, 1 and iso and iso. So these numbers, can they really bring out a quadratic coefficient of negative 3? A linear coefficient of negative 3, that yes, if they are given different signs. So if I have a negative 1 and then a negative 2, combine them, they will bring a negative 3. On addition, their sum. When I multiply negative by negative, I'll get a positive. 1 times 2, I'll get a 2. So these are the needed factors. However, the quadratic equation is in terms of p. So this one will become a 1p, and this one will become a negative 2p. So instead of writing the whole of negative 3p, we are going to write it in terms of these factors. For those who have just joined this level and you missed out factorization of quadratic expressions in junior level, ordinary level, you again missed it when we're introducing indices, this is your turn. I'm going to do it for only this example. So we are going to see that this becomes, our equation becomes a p squared, okay, minus 1p, which is the same as p. Talking about yourself as 1 Sulait is the same as saying Sulait. So there's no need of saying 1p. So it's the same as p. Very interesting. Then minus 2p. What you are seeing here is a negative 3p. We are rewriting this equation in terms of these factors. So plus 2 is equal to 0. It's like at home, you had the father, the mother, and the house girl. When it reaches night, the mother, the father, they go and rest. Then the house girl is alone. So we are looking for a companion for this house girl, such that she's not also bored in her room. So what happens? Okay, we are going to reach night when everybody now goes in the room. Negative 2p plus 2. Every pair is now in their room. So what are we trying to mean? That pick a pair, enclose it with its signs. You're seeing I'm getting a negative 2p plus a 2, this pair. Nearby pair, enclose it. You're getting 2 pairs, add them with their signs. Then start recognizing common factors. So p squared cannot be a common factor. Always the smaller becomes a factor if it has some resemblance with the another. So p power 1 becomes a factor. So I factorize it here. What remains here is we get a p squared divided by p. By second law of indices, we shall remain with a p power 1 minus p divided by p. What is existing divided by our factor? You get a 1. Good. It is the same thing we are going to do here. But people should note, for quadratic equations, normally, the bracket you get here is always the same bracket you get here. So you may not take a lot, you may avoid that time of factorizing. Just pick this bracket and put it here. And then ask yourself, what am I going to put out here such that when it goes inside, it changes the whole of this to the previous format? Automatically, that is a negative 2. Negative 2 comes here, I'm seeing a negative 2p. Negative 2 comes here, I'm seeing a positive 2. Automatically, so this is equal to 0. Since it is factorization, look for a common factor. A bracket again has become a common factor. Pull it out. So a bracket is a common factor into, get our element divided through by the factor. So the whole of this divided by p minus 1. P minus 1 will cancel. What remains here is a p. So this is a p. So the whole of this divided by our factor. So the whole of this divided by factor, the bracket cancels. We remain with a negative 2 is equal to 0. So this is the factorized format. When there is no addition or subtraction existing between a pair of brackets, then we shall say we have amicably factorized a quadratic equation or expression. Okay, that's why I got it here. So I skipped all these steps and just came to this. You can also gain that confidence. You can have that expertise one day and you just extract, calculate it from the head and put it here. It is very possible. So either, if we reach this stage, we get the values of p. So either p is equal to 1 or a p is equal to 2. We have individually equated each bracket to 0 to produce these values. Okay? So if that is true, then we are going to say, Mr. Examiner, sir, 4. Because what was asked in the question was solving for x. The examiner has no knowledge about your p. It's you who let log by 3 of x is equal to p. So for p is equal to 1, for p is equal to 1, Mr. Examiner, sir, we are going to see that log by 3 of x is going to be equivalent to 1. Because you said log by 3 of x is supposed to be p. And the first value of p is 1. By definition of logarithms, why did we talk about logarithms? A logarithm is an index. So 1 is a power, but a power is always on the base. The base is 3. So which means that x, the number, is equal to the base and the index. Very interesting. So therefore, all this implies that the value of x for this arrangement is 3. Then, for another value of p, for p is equal to 2, it implies that log by 3 of x is equal to 2. By definition of logarithm, a logarithm of a number is an index. Okay? Is an index. So, which means x is equal to the base, and then index is a power. So, x therefore is equal to 3 squared, which is a 9. So, this implies that. So in most cases, examiners might be giving only one answer mark for both values of x. So come here on a linear, on a new line and say that therefore x is equal to 3 or x is equal to 9. You can use the either sign, such that when he's giving only one answer mark, it is possible for him to just insert it here. Very interesting. So that has been our example 3. I've provided a very good posture. Pause. Write what is on the board. Immediately after the break, Teacher Sulait is coming with another example. Don't go away. Stay tuned. Yes, dear viewers, we'll be back from the break. Teacher Sulait is still your teacher tonight. We have now gone to example 4. Hope you are enjoying the topic of logarithms, part of algebra, all the way from the book of Algebra and Algebra. Okay, so let us go and see the example 4. So in the solution, first of all, we need to read the question, understand. If log base 2 of x plus log base 4 of x plus log base 16 of x is equal to 21 over 4. Find x. Is it possible to find x? Oh, let us cause correct changes. My dear students, we are not interested in the answer. A mathematician will never ever be interested in the answer. Being interested in the answer will consume a lot of your time. What are you supposed to be interested in? Correct changes. Focus on causing a change on the current state of the number. So let us go and extract our equation into our workspace. So we are going to say, Mr. Examiner, sir, you have given us log base 2 of x plus log base 4 of x plus log base 16 of x, which is equivalent to 21 over 4. But by inspection, the bases are not the same. They are different. However, we are seeing 16, the greatest base, is a multiple of 2. 4 is also a multiple of 2. So 2 is the smallest factor. So can we go and convert the base to the smallest denomination? So we are going to change to base 2. You can talk to the examiner or you can just start it on directly. So we are having a log base 2 of x, then plus, we are changing this to base 2 using the change base rule. So this is log base 2 of x, of our number, then over log base 2, what has been the base becomes the number of 4. This is now the correct change and we expect a mark at the end of it. So this is log base 2 of x over log base 2 of 16. Very interesting. And it is equivalent to 21 over 4. The right hand side has not yet simplified because 21 cannot, a 4 cannot divide 21 amicably without a remainder. So let us just keep it at that state. Now let us proceed. What can I see? I'm seeing a 4 is the same as a 4 is the same as 2 squared. A 16 is the same as 2 power 4. Oh, then that is very interesting. We can go and cause that change. So this is now going to be log base 2 of x plus log base 2 of x over 2. Do you know where I'm getting the 2 from? From here. 4 is the same as 2 squared. From the third law of indices, a 2 comes in front. We remain with 2 log base 2 of 2. But log base 2 of 2 is 1. So we remain with the 1 times 2, which is a 2. It's the same thing we are going to do here. Okay. So we can go ahead and say, Mr. Examiner, sir, this is log base 2 of x over, okay. So the same applies to this. A 16 is 2 power 4. A power comes in front. We remain with log base 2 of 2, which is 1. So here we are going to put a 4. We are just going to put a 4. So this is equivalent to 21 over 4. Very interesting. Try to get the common denominator of the left-hand side. So common denominator is going to be by 4. Or we can multiply through by 4, by 4, by 4. But the 4, we put it on the left-hand side, on the left of the logarithm. Because once it is put in the right of the logarithm, it means it is also part of the logarithm. So we put it behind, okay, or before the logarithm. So if we multiply through by 4, this will now become, we are changing space, we shall now have a 4 log base 2 of x. We are trying to multiply through by 4 on both sides. So times 4, okay, a 2 goes, it reduces a 4 to a 2. So plus 2 log base 2 of x. Very interesting. By 4, the 4 crosses out with the 4. We remain with a 1 log base 2 of x is equal to what you have done this side. You are doing it on the other side. By 4, oh, by 4, by 4, by 4. So we remain with a 21. So this is a 21. Oh, we are coming to a linear equation. Now, when I look at this by inspection, you should be a very, very good inspector if you're a mathematician. I'm seeing this is the same as that. It is log base 2 of x, log base 2 of x, log base 2 of x. It's like now having 4x plus 2x plus 1 egg or an egg. What do you get? 4x plus 2x, what do you get? Those are 6x. 6x plus an egg, what do you get? Those are 7 eggs. So we are getting 7 eggs. Okay, 7 eggs. The egg is the log base 2 of x, which is equivalent to 21. Very interesting. We can divide through by 7 by 7. Very interesting. Or you can multiply through by 1 over 7 times 1 over 7. Anything you feel like. So we shall get a log base 2 of x, which is equivalent to 21 over 7. And 21 over 7 is, it is a 3. Okay, so this is a 3. Then by definition, logarithm of a number is an index, meaning that 3 is the index. Index means power, but a power cannot exist on its own without a base. What is a base? The base here is 2. So meaning that x is equal to the base power, the index. Okay, so therefore x is equal to 2 power 3, which is the same as 2 times 2 times 2, which is 4 times 2, which is equivalent to 8. A very simple number. That is our number 4. I've given you a clear posture. What you have to do is to pause. Write down the work you are seeing on the board for revision purposes. Scientists have proved to us, they have proven it beyond doubt, that there is communication between your fingers and the brain. The work you write with your fingers is totally different from the work you just watch or you just read, work which you did not write. So, never to make your own notes. Immediately after break, I'm adding you more examples. Don't go away, stay tuned. Dear viewers, we'll be back from the break. We are now set for example 5. So example 5, the examiner is telling us to determine the possible values of x in the equation log base 2 of x, log base x of 64 is equal to 5. So just as before, we can go and pose a change. So we shall go and say, Mr. Examiner, sir, this is the solution. This is our solution. Okay, where is our marker? Okay, now in this kind of arrangement, we can extract our mathematical expression or equation, that is log base 2 of x, then plus the log base x of 64, which is equivalent to a 5. Very interesting. So what can we see? We can see that the bases are not the same. So if the bases are not the same, and having a base as an unknown is also very dangerous. So let us change to base 2, which is the smallest here. So let us go and say, changing base to 2. So this is going to be log base 2 of x. This is already to base 2. Then plus log base 2 of 64. Then over log base 2 of x. Okay. This is going to be equivalent to a 5. So this is a very, very good start. When we prime factorize 64 to resemble 2, it is going to be in form of 2 to a given power. And that power is going to be 6. You can go and use the ladder method, try to prime factorize. So we shall go and say, Mr. Examiner, sir, this implies that we are causing another change. Log base 2 of 2 power 6 over log base 2 of x is equal to a 5. That is our stand. So we accept that a 6 comes here. Log base 2 of 2 is 1. So we shall remain with the 6 up here. Very interesting. So this implies that, Mr. Examiner, sir, our expression becomes log base 2 of x. Log base 2 of x. Log base 2 of x. Then plus a 6 over log base 2 of x, which is equivalent to a 5. Very interesting. So you can multiply through by log base 2 of x. If it is difficult for you, you can let log base 2 of x be a particular unknown. I can call it z. So I can go and say, Mr. Examiner, sir, let log base 2 of x be equivalent to a z. So where there is log base 2 of x, I'm going to put a z. So this implies that I'm getting a z plus 6 over z is equivalent to a 5. I've changed this equation to this format. I can multiply it through by a z and rearrange, giving me now a z squared minus 5z plus 6 is equal to 0. This is a quadratic equation. Okay, so this quadratic equation with the linear quadratic coefficient can be factorized easily. So when you factorize this, we shall get z minus 2, okay, minus 2z. Okay, we are making a complete factorization. So it becomes z minus 2 into z minus 3 is equal to z is equal to 0. Okay, because these two factors, once multiplied, negative negative will give me a positive 6. When added, they will give me a negative 5. Since it is linear, that's why I'm just bringing it direct. Very easy. Now, we can proceed and say that Mr. Examiner, sir, either, okay, z is equal to 2 or z is equal to 3. Individually equating each of these brackets to 0. What does that mean? It means that you let log base 2 of x equivalent to z. So for z is equal to 2, okay, it implies that log base 2 of x is the one which is equivalent to 2. By definition of logarithms, okay, this is an index. Logarithm to a given base is an index. This is the number. So our number is now going to be the base to a given power. So therefore, x is equal to a 4. Very interesting in that kind of array, arrangement. Then 4, okay, for z is equal to 3, we shall say that log base 2 of x is equivalent to 3. So by definition, logarithm of a number to a given base is an index. So this is the power, is the index. The base is already here. Okay, so we are going to say this implies that x is equal to a 2 power 3, implying that x is equal to 8. So those are the two answers which we have. So we can conclusively go and say that therefore x is equal to 4, that is the either part, or x is equal to 8. So those are the possible values of x. So the work is always very interesting. Look at the smartness displayed. Equal signs in the same order, That's what we are looking from you. You just need to focus on an existing step. If it is correct, it will push you to another step. Applying the laws, principles, which govern that particular topic. Immediately after break, we are meeting for another example.